Okay, good afternoon, everyone. Yeah, so today I am taking the class from home because the earlier class was a tutorial for this week. So I just had another 2-hour tutorial session and now another 2-hour recitation session. So hopefully my voice stays till the end. I think should be fine. All right, so this second recitation is where we will wrap up C programming. Okay, so definitely it has been a huge information overload for you, correct? Trying to squeeze so much of stuff about C programming and trying to learn it in just 2 weeks, so much of stuff. Yeah, so what we are again covering is just in a sense touch and go, correct? We're trying to cover a lot of things, but at a very basic level, so you understand how C works. And again, you will come back to see in future modules 2106 and so on. Okay, so these concepts will definitely be helpful. And I think another reason why we need C is because when we are learning MIPS, we will also see how C relates to lower level assembly and the hardware later on. Okay, so that is where the link comes in. All right, so it will all come together, okay, as we progress along this module. Okay, but this is basically the last recitation on C. Okay, after that, next week onwards, we will go on to MIPS. Okay, so let's get started. Okay, so in terms of structure, what I will be doing is I'll be going through some Slido topics discussion first. Okay, so I saw the Slido, all the questions that were posed, and so generally there is a lot of I would say confusion about how we deal with address and pointers and so on. Okay, so this seems to be a common question, okay, that I saw in the Slido sort of questions that were registered. Okay, and also some on the string. Okay, so I'm going to sort of run through with you some important concepts, okay, using a demo. Okay, and hopefully that sort of clears things up. Okay, and whatever doubts that you have. All right, so let me bring out this one first. Okay, so so here what I've done is I've created, okay, from the program here you can see that I've created using three different data types, three different variables type as well. Okay, so so the three data types are character, integer, and double. Okay, and I'm going to create an individual sort of variable based on each data type. I'm going to create an array of each data type, and I'm also going to create a pointer of each data type. Okay, and we're going to sort of see step by step how this sort of plays, okay, into addressing in C, okay, and how we relate to it. Okay, so the first thing is what I'm going to do is I'm going to print out the size of. Okay, so this size of is a built-in C function where you can use it to print out the size or the number of bytes used by a particular variable. Okay, again, this is a bit dependent on a few factors. Could be the underlying operating system you're using, the compiler version you're using, and so on. Okay, generally character is fixed, okay, but integer, float, and double may vary, okay, across different systems. Okay, but again, you don't need to be too worried about the actual numbers, okay, but more on how we relate the numbers. Okay, so that is what I want us to see. Okay, so let me run this first. Okay, so you can see down here what you have is a character variable. Here is printed out as using 1 byte, an integer is 4 byte, and a double variable is 8 byte. Okay, so what does that mean? Okay, that means when I declare this, okay, so okay, so when I declare these variables over here, okay, somewhere in memory, I will create a character variable. Somewhere in memory, I will create a integer variable, and somewhere in memory, I will create a double variable. Okay, the size, again, in this case, this is 1 byte, this is 4 bytes, and this is 8 bytes. All right, so that is what happens when I create these 3 variables. Okay, so it occupies 1 byte, 4 bytes, or 8 bytes, okay, somewhere in my memory. All right, now the next thing I'm going to do is I'm going to print out, okay, the address. Okay, so besides the variable, I'm also going to print out the address of the first and second element of the arrays over here. So what I've done here is I've also created character array, integer array, and double array. Okay, that means in memory I have a character array. Okay, that means 4 characters. Okay, and I have another integer array, 4 integers. And I also have another double array. Okay, 4 doubles. Okay, and what I'm going to do is I'm going to print out the address of the first element. So element 0 and element 1 of each of these array elements. Okay, so to see how it is done. Okay, so you can see down here, I print out the address of each element, each array, element 0 and element 1. So I do it for all the 3 types. Okay, so let me run it. Okay, so let's see what you have here. So you can see down here, okay, that the address values that you get over here, okay, for character array, you can see that subsequent elements from 0 to 1, the change is also only by 1, from 04 to 05. Okay, that means if this is occupying an address where the last byte value is 04, the next one will be +1, 05. And why is that so? Because a character occupies 1 byte. So in a character array, every subsequent element also is occupying a space 1 byte away. Okay. Percentage P, percentage X both work the same way. Okay, so I'm used to using percentage X, but I think in the lecture slides you're using percentage P, it's fine. Okay. So over here for integer array, you can see that from 0 to 1, the address is increasing by 4. Okay, that means if this starting address is, for example, D0, I need to +4, then I go to D4. And why is that so? Again, comes back to this. An integer variable occupies 4 bytes, which means that when I go to subsequent array elements, I increment the address by 1, but it's actually incrementing by 4 bytes. All right. Whereas in a character array, when I increment the index by 1, it is incrementing by 1 byte. Okay. And if you look at for the case of double, okay, the double array increments by 8 bytes. Again, it comes back to the size of the double. Okay. So if this is E0, then the next one is +8. So it becomes E8. Okay, so when it comes to array elements, all right, it comes down to the size of the data type. The subsequent array elements occupy the number of bytes depending on the data type that you are using. Okay, so that is the second thing that I saw from the questions that was that I wanted to clarify. Now the next thing is, well, how do pointers come in? So I've also declared the 3 different type of pointers, okay, character, integer, and double pointer. And now I'm going to print out the size of each of the pointers. Okay, size of character, pointer, integer, pointer, double pointer. Okay, now let's see what we get over here. Now you can see that the size of all 3 pointers here is 8, 8, 8, 8. Regardless of whether I am going to run it as regardless of whether it is a character pointer, integer pointer, or double pointer. Now, why is this all 8? Even though the value you're pointing to is or the data type you're pointing to is different. Okay, because this is related to pointing to an address. When you create a pointer, you are pointing to an address. That means this relates to the amount of address space you have in your system. Okay, so again, this may vary from system to system. In some cases, the pointer might be 4 bytes, some cases might be 8 bytes, and so on. Okay, so it depends on how big is the address space. So like I said just now, when I create a variable, I set aside some storage space in memory. Okay, so you in the memory, of course, memory itself has very different segments and so on. Okay, so in a sense, when you create variables, you're occupying the RAM space. Okay, so when you occupy this, okay, you need to be able to point to where this is stored in memory. So when I say that, okay, I have a certain amount of address space. Okay, so this is the start, this is the end. Again, it depends on how much address space I have. Okay, so again, it comes back to 64 bit system or 32-bit system. Okay, so that sort of relates to how many bytes that you have. Okay, so if I say I'm using a 32-bit system, then I occupy the full 32-bit address space. A 64-bit system, entire 64-bit address space. All right, so the pointer, okay, the pointer will have to be able to point. So when I create a car pointer or an integer pointer, double pointer, I must be able to point to anywhere within the address space to access this variable. So that is why the size of the pointer is always consistent, because that is related to the address that I'm going to point to. Okay, so that is the size of the pointer itself. Okay, now the next thing that I'm going to do is I'm going to allocate. So I'm going to assign the pointer to point to the array. So the character pointer is going to point to the character array, integer pointer going to point to integer array, and double pointer is going to point to the double array. Okay, so what is happening now is I have created 3 pointers. Correct. So the ch pointer is going to point to character array. Okay, the integer pointer is going to point to the integer array, and the double pointer is going to point to the double array. Okay, so that is what these 3 lines over here do. I am assigning the address of the arrays to the pointer. Okay, now what I'm going to do is I'm going to print out the current address, okay, that is stored within the pointer, and then I'm going to increment the pointer by 1. Okay, and then print out the new address. Okay, and I'm doing it for all the 3 types: integer, character, integer, and double. Okay, so what I'm doing, I'm going to print the current address, which means the start of the array, and then I'm going to increment the pointer by 1, that means plus plus, and then the new value. Okay, so let's see what happens. Okay, what this? Okay, so let me take this output here. Now, what do you notice? You notice that when the character pointer increments, it is equivalent to the same way in which the address of address also changes when you do array indexing. So for character pointer plus plus, it is also increment by 1. Okay, for integer, okay, you increment by 4, and for double, you increment by 8. Okay, so again, what it tells you that the pointer, though it points to any address, when you do anything associated with a pointer, that means you're changing the actual address held in the pointer, it relates and comes back to the data type that you're pointing to, whether you're pointing to a character, integer, or a double, or whatever. Okay, so this is the thing I think most of you were confused, okay, from the Slido question. Okay, why is it sometimes when I plus is +1 or is it +4? Okay, it comes down to the data type. Okay, depending on the data type, you will increment the value, okay, of the address that is held in a pointer or the address of subsequent elements in the array. Okay, so that is again, I hope this sort of clears up this doubt. Does anybody have anything you want to ask about this part first, this array indexing and pointer addressing and so on? Okay, where can you find this source code? Okay, this source code is my one. If you want, I can send you all later. Okay, so this is just something that I wrote up just to demo, okay, all these concepts, so it is a bit clearer on what is happening. Okay, so the next sort of thing that I saw was string assignment and how it is stored in memory. Okay, so let me open up that code there, and then demonstrate that. Okay, so here what I've done is I've created a simple code, okay, where I assign a string, okay, with a name John Tan, okay, to the character array, okay, and I'm going to print out the name and the length. All right, so let's run this first. Okay, so you can see the name John Tan. Okay, when you use string copy, the name gets copied over, and the length, okay, based on the string length function, returns 8, which is 8 characters. Okay, so it doesn't include the null character. Okay, so where is the null character? Okay, how do I see it? So for us to see where this null character is in memory, okay, we are going to print out, okay, character by character. Okay, and what I'm going to do is I'm going to use a pointer. Do I need a pointer? No, I'm not using a pointer. Sorry, I'm just using a loop. And I'm going to print out two formats. One is the hexadecimal version. The other is the actual character version. Okay, character by character. Okay, and you see what we get. Okay, so what do you see? You see that John Tan here. Okay, you can see that these characters, you can go back and look at your ASCII table. Okay, so each of this corresponds to the ASCII. So this is capital J, this is small o, and so on. So these are the actual values based on the ASCII table. All right, and after the last character is where you see a null character. Okay, so that is why when you do a print, okay, the moment it sees the null character, it stops. Okay, so that is the end of the string. Okay, that is how you calculate the string length and so on. All right, so in general, when you create a string, okay, it is effectively a character array, except that it is terminated with a null, okay, which sort of makes it behave as a proper string. Okay, if you don't put the null, then it behaves just as a normal character. Okay, so if you use all 10 characters, to storm, then the null may still get appended. Okay, but it is not guaranteed to be there all the time. Okay, so for example, okay, so let me change the name a bit. So now it's 8 characters. Okay, so let me put in 2 spaces. Okay, so 4, 8, 7, 8, okay, and I'm going to run this loop for maybe 12 times. Okay, now a bit more. Okay, so the character array length is still the same, but now I'm using the full 10 spaces. All right, now if I save and run this, okay, so what happens is it still puts in null. Okay, but this null, this is not guaranteed. Okay, what do I mean by not guaranteed to be? I mean, it's not guaranteed to be there beyond this instance when you first created the variable. Okay, why? Because when I do this, okay, this is equivalent to saying that I have 10 array elements, correct? So this is your name, 10. So from element 0 all the way to 9, you already have. Okay, and now it just so happened that the 10 you put in the null character. Okay, now this is actually considered a free space by the compiler. All right, that means subsequently, if the other variables declared, you use some other dynamic memory allocation function, the compiler or your program while it is running is free to take this space and use it for something else. Okay, and when that happens, then subsequently when you try to print John Tan, this null may not be there. So it could be some other data, which means that the printf will continue until it gets some null. Okay, so it may seem correct, okay, but it's not actually correct because that space is a free space, which means that it can still be overwritten with something else. Okay, so the printf will run and will try to print until it detects that it is a null character, because it does not know what exactly is in the string. So the printf will print until it detects the null. So if you don't want to let's say use printf, then you can also do manual printing by character or some other string function. Okay, so let's try this. Okay, so we can always try and see what happens. Correct. So in this case, let's assume that right now I am going to let me assign a pointer here. So you saw what happened? I intentionally overwrote the null character. Okay, I intentionally overwrote the null character by forcing it to a value other than null. Correct. So when it start to print, it just continue to print. Again, in this case, it just terminated based on the loop. Okay, if I were to run it as an infinite loop, then it will just keep running. Okay, until it detects a null or some memory crash happens. Okay, so again, these are some of the things that we need to be careful about with strings. Okay, so those are the Slido questions. I mean, the general discussion based on the Slido questions. So let's move on. Okay, so to make things, okay, let me bring it here. Okay, so we're going to have a simple one question quiz. Okay, so using poll everywhere. Okay, so can you open up your handphone? Okay, it's only one question. So you can go to the link first, pollev.com/rsnus. Okay, so this is based on last week's topic. Okay, but it's an interesting piece of code that I just wanted to show you. Okay, so I hope you all are ready. You have 40 seconds, I think, to answer. Okay, so the time is up. Total 68 people answered. Okay, wait, let's answer. Okay, so what is the correct answer? How come I never show the correct answer? Okay. Okay, so I'm not sure what happened. Okay, now bye. So let me go through the question. Not sure why I never show the correct answer just now. Okay, let me run the code for you. Okay, so this is the code. Okay, so if I run it, it will print as false. Okay, it's print as false. Okay, so I'm comparing C greater than B greater than A. So 30 greater than 20 greater than 10. Okay, so mathematically, yes, 30 is greater than 20, 20 is greater than 10. Okay, but yet it prints as false. Correct, it prints as false. Okay, why? Because when I run this code, okay, what happens is this. Okay, so those of you who know, this is a logic evaluation, correct? So 30 greater than 20 means it is true, so it will be 1. And 1 greater than 10 will be false, which will be 0. So that is why it prints out as false. Okay, so again, this is just to highlight that you cannot sometimes apply the same sort of mathematical thinking process directly to code. Right, you need to break it up part by part. So you need to put C greater than B and B greater than A and so on. Okay, so that sort of again just to tickle your mind. So let's continue to the questions here. Okay, so let me okay, so we'll proceed on to discuss the quiz questions, and then we have some extra questions, and then yeah, and then we can wrap it up. Okay, so let me okay, these are the quiz questions. Okay, so is it possible for C greater than B to get a value of 11? No. Okay, so the evaluation of logic expression always comes to only 1 or 0. Okay, when it is comparing any value greater than 0, other than 0 is considered true. But the outcome of the comparison is always 0 or 1. Okay, so let's come here. So in this question, I think some of the questions should be quite straightforward. All right, considering that you have already gone through the quiz. So in this case, you have p x. So you have x variable having an address 1558, and you have another variable y having an address 1562. Okay, and p is a pointer pointing to x. So p is a pointer pointing to x. That means the address of x is inside p. And q is a pointer pointing to y. That means the address of y is inside q. All right. So we know x has a value of 5 and y has a value of 2. And when I do this line, asterisk p equals to asterisk q plus 1. So whatever q is pointing to, so q is pointing to 2. So this is 2. And plus 1 will give me 3. So 3 goes into p. Okay, so that is the first question. I think as long as you understand the concept of pointers. So I would say pointers are one of the most powerful things of C that has still sort of kept it at the top of the list. Okay, when it comes to low-level hardware and designing sort of embedded systems and so on. All right, because later I'll show you another demo. All right, but you can see that pointers are amazing. Okay, they can really give you the power to point to anything and anywhere in the system. Okay, if I know the address, I can get to it and I can do anything I want. Okay, that is how powerful pointers are. All right, so of course, as they say, with great power comes great responsibility. Correct. So of course, not everybody is responsible. So we also need to design sort of protection mechanisms at the hardware level to prevent people from messing things up. Okay, so for example, if you were to write an app, and somehow you write use a pointer that will point to somewhere that is going to corrupt the OS, and then because of the app your whole phone crashes, then that is not something that you want. Correct. So we want to be able to protect certain parts of the system that even if you manage to point to there, you can't do anything to it. Okay, so again, these are things that we will cover later on. Okay, when you talk about cache, memory management, and so on. Okay, so there are some protection mechanisms in place so that even if the person writing a software tries or even accidentally does something, you can still protect the base system. Okay, so there's a question. If there's no null character, it is still recognized by computer as a string. Okay, so it is still recognized in the sense that as long as it is a character array, okay, and you start to print, it will start to print. Okay, but the issue is if there's no null character, then you do not know when it will terminate. Okay, which is quite dangerous, correct? It may end up printing infinitely or it might crash the system or something like that. Okay, so that is why we must always make sure that a proper string is there before you try to print it, okay, to the console or anything. Okay, next question here. Okay, so here we are looking at the concept of a pointer to a pointer. Okay, a pointer to a pointer. So what you have here is, again, you have x variable, okay, the address of 1558. You have another variable y 1562. Okay, you have a pointer p that is pointing to p is pointing to x. So 1558 is here. Okay, so p is pointing to x, and you have another pointer q. So q is a pointer to a pointer, and q is pointing to p. So the address of P, which is 1550, will be inside Q because Q is pointing to P. Okay, so when I do this P plus plus, okay, P plus plus, I am incrementing it by 1. Okay, that means currently it is P is pointing, P has a value of 1558 and I plus 4. Okay, so why again I plus 4? Because it is a integer. Okay, the integer. So I'll get 1562. Okay, so I'll get 1562. That means the value in P is now 1562. Okay, so before we proceed, an important thing that you must remember is this is just an example that shows that two variables declared separately are side by side in memory. But this is not at all guaranteed. The only time you can guarantee that they are side by side in memory is if they are in an array. Okay, if they're not in an array, it is random allocation. It could be side by side. Okay, it could be. Okay, you may run the code and many times you will keep running, it's always side by side, but it is not guaranteed. Okay, it could be that the 100th time you run, suddenly it is somewhere else. Okay, so do not assume that this is the case. Two variables declared side by side will always occupy adjacent addresses. No, only in the case of an array that is true. Okay, so in this example, that's why we have explicitly given you the address that it happens to be that they are both side by side. Okay, so P plus plus in this case is go 1562, and 1562 happens to be the address of Y, which means that P is now technically pointing to Y. Okay, so now when I say so the value here is X is 5 and Y is 6. Okay, so when I say asterisk P minus minus, okay, when I do this asterisk P minus minus, that means whatever P is pointing to. So what is P pointing to? P is pointing to this location 1562 and has a value of 6. So 6 minus minus will give me 5. So this will become 5. All right. Now the next line. Okay, the next line that says asterisk asterisk Q plus plus. That means whatever Q is pointing to and whatever that is pointing to. So Q is pointing to P and P is pointing to Y, correct? Because the address is 1562. So this is now value is 5, and now 5 plus plus will give me 6. So this will now go back to being 6. Okay, so that is how you look at this question over here. Okay. Okay, so there's a question, if X is integer and Y is double, and if I do plus plus, okay, will it increment by 4 or 8 and so on? So okay, so this one is casting of pointers. All right, by right you are by default, okay, by default you create pointers to point the same data type. Okay, but C allows the casting operation, which means you can cast one data type to point to another data type. Okay, so I'll come back to this later. Okay, I'll come back to this question later when I show another demo later on. Okay, how pointers behave when you do casting from one data type to another data type. Okay, so let me move on first. Okay, I'll come back to that concept later. Now this question here. So you have a function and this code fragment. Okay, so let's look at what is happening. So here first I create a variable 2. Okay, so I have a variable a as a value of 2. Okay, then I create another pointer p, another variable pointer p, and p. So I call a function fun and I pass in the address. So this is passing by reference, correct? That means in this case, x is eventually pointing back to a. That means whatever you do to asterisk x is effectively doing back to the a back here in the main function. Okay, so I'm effectively passing the address. So x, so inside my function, okay, x is a pointer. Okay, so if let's say a address is 1004, then the value 1004 will come here. Correct? Whatever address of a, okay, is passed over to x. Okay, so effectively x is now pointing back to the a, the main function. Okay, now when I do this line, okay, asterisk x multiply equals to 2, that means whatever I'm pointing to. So what am I pointing to? I'm pointing to a. So a is a value of 2. So 2 multiply equals to 2 will give me 4. So this will become 4. Okay, and now I've completed the operation and I return x. So when I return x, I'm actually returning this. Okay, and when I return, I'm capturing it through p. So this is now transferred back to p. So p is now having a value of 1004, which means that p is now pointing to a. Okay, now p is pointing to a. Okay, so when I do asterisk p minus minus, so what is asterisk p? What is p pointing to? So p is pointing to a, which means it's a value of 4. Minus minus will give me a value of 3. Okay, so that's how you get the final answer of 3 over here. Okay, so so again, if you have questions, just feel free to ask. If not, I will go ahead. Okay. Okay, next on the arrays, strings, and structures. Okay, so we moved from the pointers and moving on to the array, strings, and structures. So here what you have is you have integer array and you call function x2. So when you call function x2, basically what are you doing? You are passing in x parameter 2. So this is index 0, this is 1, this is 2. So I'm passing in x2. So x2 in this case is actually equals to value 1. So I'm passing in a value 1 over here and I'm multiplying it. All right. But when you multiply it, what happens? It is a local variable. Okay, y is considered a local variable, which means that once you come out of it, you don't have access to it anymore. Okay, so when you, and this is passing by value, not by reference. All right. So when you pass by value means you are creating a copy of the variable and passing it over to the function. Okay, so these are considered two separate memory spaces. When you pass by reference, which is through the pointer, you're pointing back to the same memory location. When you pass by value, you're only passing a copy of the data. Okay, so whatever you do in function f does not affect the actual variable. So you still print out the same value, which is 1. Okay, so the same value 1 is the one that gets printed out. So I think this one should be quite easy. Okay, let's look at the next code fragment here. Okay, so here we have an array, and now what I'm doing is I'm having a function and I'm passing in the address of element 1. Okay, so let's look at the array A. So the array A has 4 elements. Okay, 1, 1, 3, 2, 5, and this is index 0, index 1, index 2, and index 3. Okay, based on the array A. So when I pass in the address of A1 to P, so P is now pointing to A1. So P is pointing to A1 over here. So if P is pointing to A1, this is equivalent to P minus 1. Okay, this is equivalent to P plus 1 and P plus 2. And this is P plus 2. Okay. So with this, asterisk P minus 1 is 1. So this will be 1. Asterisk P plus 1 will be 2. And asterisk P plus 2 will be 5. So effectively, you are doing 1 plus 2 minus 5, which is minus 2. All right. So what I think this is trying to show you is when you pass, all right, you can choose to pass a portion of your array to another function. Okay, to do something, you don't need to always pass the whole array. Okay, you can choose to pass a specific element. Okay, and even if you pass even one address, with that one address, you can also reference and point back to the rest. Okay, so you see, I didn't have to pass the starting address. I can pass any address, but I can still use that to sort of access the other elements in the array. Okay, so that is what this is trying to show you. Okay, so this question is on strings. Okay, so this here you create a string. Okay, so in this string array, basically what you have is cats. Okay, C-A-T-S. All right, and I'm pass this string to this function character with a pointer. So C is effectively pointing to string. So whenever you pass an array to a pointer, this pointer is effectively pointing to the first element in the array. Okay, the name of the array is always the address of the first element in the array. So C is pointing to C. So C is pointing to the string. Okay, the start of the string or the first element in the string. So while asterisk C means I will continue this loop until I hit the null character. All right, and what do I do in the loop? I take whatever value I'm pointing to and I increment it by 1. So in terms of character, when I say increment by 1, what does that mean? That means you go back in a sense to the ASCII table, but the ASCII table goes for numbers and alphabets, they go in the normal order. So whenever you have a character, +1 is always the next alphabet, -1 is the previous alphabet. Okay, so if I say C is my current alphabet, if I want to increment the value, automatically it will become D. Okay, so whatever I'm pointing to, I increment, and after that I plus plus. When I say plus plus, as we saw just now, since I point to a character array, when I plus plus, I will point to the next element in the character. That means I increment by 1 byte. So plus plus will point me here, and then I do the same thing. So A will become B, T will become U, and S will become T. Okay, after that you will see the null character and then you will stop. Okay, so that is basically what this does. Okay, now let's move on to structure. Okay, so there are 2 questions on structures. Okay, so structure in a sense is a very powerful way of organizing your data. Okay, because you can group together different data types into one sort of higher level variable, okay, and use that to store a lot of information, correct? And it becomes very easy to move data around, and sort of order things and so on. So it's a very good way of storing information, okay, depending on the kind of data you're dealing with. Okay, so whenever you have structures, the good practice is always to use type define. So when you use type define, you are specifying a new variable data type. Okay, so when you create a new data type, you use that to create the variables based on this new data type. So in this case, when you say type define struct integer x, okay, what it does is it creates a new data type, and when I create a variable from that, okay, so when I say t test t1, okay, when I say t test t1, so in memory, what will you see in memory? You will see it has two portions. T1 or any structure variable has two portions. One would be an integer, and the other is the character. So every variable declared with this data type will have two portions. Okay, so there's a question in the cats, is the null character always appended? So when you declare it as a string, that means you put double quotes and you put a string, automatically the null character is appended. Okay, if you put it as individual characters, then you need to manually put in the null. Okay, so in this case t1, okay, every variable created with this new data type t test will always have this organization in the memory. That means it will be an integer followed by 32 bytes of a character array. Okay, so in this example, what is happening is I first declare t1 and I assign the variables to the or assign values to the variable. So 5 goes into the integer, hello world goes into the string. Okay, then I call function f, I pass in t1. So when I pass t1, this is passing by what? Passing by value. That means a local copy is made. Okay, a local copy is made. So within this f, I create a new t1. So this t1 and this t1 are not the same. They are not the same. Okay, though they have the same name, this t1 is still local to main. This t1 in f is local to f. All right. So over here, what do? I take t1.x. So whenever I want to, so this t1 over here already has the same data. That means it already has value of 5 and hello world. Okay. Now when I do t1.x minus minus, this will change. So this will become 4. Okay. And when I update the string, this will also change. This will also be penguin. Okay. Now what do? I take t1, copy it to temp, variable that I've created, and then I return it. So when I return it, what happens? When I return it, it goes into t2. So I'm returning, just like how I can return a normal variable, I can also return a structure. So now t2 is getting the value based on whatever that was done in the function f. So when I print out t2, okay, when I print out t2, it will be able to sort of be the updated value. T1 is still the original value, which is this 5 and hello world. T2 will be the new value, which is 4 and penguin. Okay, so that is again passing by value. You create a local copy. Okay, our struct stored in contiguous block in memory. So all the elements of the struct are contiguous. That means, like I said, if you look at t-test, when I use t-test to create t1, since t1 has an integer and character, they will be packed together. But same as before, if I create t1 and t2, they can be anywhere else in memory. If I create an array of structures, then they are all contiguous. Okay, so a structure is, again, think of it as a macro level in terms of a data type. So in terms of just integer or character, I group them together, and now I have this new data type. But the same rules still apply. Okay, the same rules still apply. Okay, so static. Okay, so when so static is not necessary here, but let me just show you. Okay, what does static do? Okay, and why it is important in some cases. Okay, let me just bring up the okay, so here I have a code. Okay, so basically what I'm doing here is I have a function increment x. Okay, so let me take a copy of this so we can. Okay, so in this function, if you can see, what I'm doing is I've declared a function increment x, that inside this function I create a variable and a plus plus and I return. So inside this main loop, what I do is I run it for 5 times. Each time I call increment x. So I'm not passing in any variable. I'm just using the variable created within increment x to increment and pass it back. Okay, and I'm doing this 5 times. Now, if I run this code, okay, if I run this code over here, you'll notice that the value is always at 11. Okay, the value is always 11. All right, so why is that so? It never changes, correct? That means the very first time I call this increment function, okay, I go inside here, correct? I create a local variable x equals to 10, and then I increment, I return. So when I return, the result is 11, correct? I'll print out. Then the next iteration of the loop, what happened? I call increment x one more time. But every time I call, I create the variable again, correct? Which means it always goes back to 10 and I plus plus and I return. Okay, so it always goes back to 10, then I return 11. 10, it return 11. Okay, so it's always 11. Okay, so there are of course 2 ways to do this if I want it to retain its value. Okay, so one way is I declare it as a global variable. That means I take this and put it outside. So if I declare it's a global variable, then it will retain its value, okay, even regardless of any function call, okay, because it is not tied to any function, it's global. Okay, but again, global variables are always it's like a double-edged sword, okay, because it offers you a lot of flexibility and freedom, but if you don't use it wisely, okay, and carefully, it will mess up a lot of things. Okay, so to avoid using global variables, because you only want x to be over here, okay, what we can do is we can declare the variable as static. Okay, so if I declare the variable as static, nothing else, I just the variable alone as static, what happens is now you see that the value increments. Okay, it increments while I run the loop. Okay, so what is the key thing about static? Okay, so again, this comes down to memory allocation, which you will come to in a later topic. Okay, but basically, when you create variables in a function, okay, when you create variables in a function, okay, they use this part of the memory called the stack. Okay, which means that okay, in the stack, okay, when I go into a function, I will occupy some space in the stack. All right, once I come out of the function, I am considered to have cleared the space that I use so that I can reuse it for other functions. Okay, so that is why whatever variables you create within the function is considered lost once you come out of the function. Okay, but if I use this static keyword, what happens is instead of being in the stack segment, it goes to another part of the memory known as the data segment. Okay, and this is where you can have persistent storage. That means regardless of whether you so it will not be allocated within the stack, it will be in the data, which means that even when I exit from the function, this X is still safely stored in a separate area. So that is why it can retain the data or retain the value even after I come out of the function. Okay, if I don't use static, it's on the stack, which means that once I come out of the function, the stack is cleared, the data is gone. Okay, I mean technically the data is not gone in a sense. It is just there. It's just a matter of whether somebody overrides it or not. Okay, so when I say gone, okay, the concept is people might think, oh, I delete the data. No, you never delete the data. It is again using pointers. Okay, so I use pointers to know where I'm in the stack. All right, so when I say that I am out of the stack, that means my pointer has now moved back to maybe the top of the stack. So this is considered free, but the data is still there. It is still there. It's just a matter of whether I want to go through the trouble of going to find that address and pointing back to it and trying to retrieve my data. Okay, so as a question, wouldn't X still reinitialize to 10? So in this case, it will not reinitialize to 10 because this static variable initialization will only be done once, the very first time it is called. Okay, because this is only done in the the variable is in the stack, in the data segment. So which means that when I run it, it will retain the old value. So when I plus, it will still hold on to the updated value. The initialization, this is only done as a one time. Okay, so when you declare the static, and you have initialized the variable, that is only a one-time thing. Okay, subsequently, you always retain the last value that it has. Okay, arrays appear similar to struct due to okay, so a variable initialized with struct type. Okay, so when you declare struct variables, okay, the elements themselves, when you reference the element, that means when you say t1 dot x or t1 dot in this case c or whatever, you are referencing the variables. Okay, so as I said, you must think of structures as more of a variable, okay, rather than an array. Okay, because a structure puts together different data types together. Struct padding covered in the scores module. Okay, so padding is not covered in this module. Okay, so yeah, no, so I think padding is not covered. Yeah. Okay, so you don't need to worry about that. Okay, so I think this sort of gives you an idea why or where you should use static. Okay, if you want the data to be retained. Okay, so let me go on to this last sort of quiz question, and then we can move on to another discussion. Okay, so in this question here, you have again declared a structure. integer x, y, character C32 and so on. Okay, and you t my struct. Okay, so now in this case you are creating a function where the input is a pointer. Okay, pointer to a structure. Okay, so you have first declared structure array. Okay, T3. So it's a structure array. That means 3 elements, correct? And each structure element. Okay, so you have 3 structure elements. T0, T1, T2. So this is T0, T1, and T2. And each of this element has 3 paths to it, correct? X, Y, and C. So X, Y, and C. Okay, X, Y, and C. Okay, X, Y, and C. Okay, and then I already put in some data there, and I call function T. So when I call function T, what do? So this is an array. So the name of the array is the address of the first element. That means this asterisk T is pointing back to the start. Okay, so this T asterisk is pointing back to the first element in the array, in the structure array. Okay, so when I say T pointing to X plus plus, okay, this is pointing to the first element, okay, referencing the first variable X of the first element. So this is the thing that you're referencing, this one over here. Okay, so that is T pointing to X. All right. So when I point to T reference Y, I'm pointing to here. And T reference to C, I'm pointing to here. Okay. So when I print out, okay, it will be the X plus plus. That means this value would have incremented. This would be X plus plus. This would be 1. So this would be 1, this would be 0, and this would be yellow. Okay, so let me just show you how it sort of works, okay, in the code, and what are the variations to this. Yeah, so this is the code. Yeah, let me share. Okay, so this is the code as you have it over there. So let me save it and run it first. Yeah, so you can see that basically what is happening is I update the T X, which is the first element. Okay, so the first element in the array, the member X, member Y, and member C. So those are the ones updated. Okay, now if I wanted to update the next element, okay, if I want to update the next element, so as you can see, T is pointing to here, which means that T plus plus would point to the second element, or T plus 1. All right, so if I were to change this, okay, to say that I put it as T plus 1. Okay, then if I run this, so you see that the second element is the one that has changed. Okay, so from 1 2 world, it has become 2 1 yellow. Okay, why? Because T plus 1 is now pointing to the next element in the structure array. Okay, so let me just print out these addresses so you can see again how it relates. Okay, so now if you see this, I'm printing out the size of t my struct. So the size of t my struct is 40. Okay, why is it 40? Because I have two integers and 32. So this two integers here is 4, 4, and this is 32. So all add up together is 40. That means one structure element occupies 40 bytes. Okay, so that is why when I do +1, okay, that means the next element, okay, it is actually plus 40. So C0 plus 40 will be E8. Okay, so you can try here. Okay, C0 plus decimal 40 equals to E8. Okay, so you can see that the values are correct. So each structure element occupies 40 bytes. So when the pointer is concerned, when I do a +1, I'm actually incrementing by 40 bytes to point to the next structure element in the array. Okay. All right. So this again is to show you how we use a structure pointer to access the different elements in the array. Okay, so can we look through the elements of a structure? Yeah, I mean, you can write a loop just like this. Okay, so whenever you write a loop, you can loop through the whole structure. That means within the array, element 0, element 1, element 2. Okay, that's how the loop is here. Okay, but when you want to access each element in the array, then you either use pointer notation, okay, or the index notation. Okay, depending on whether it's a structure variable or structure pointer. Okay, so let's let me bring something out for you all to try. Okay, so this is like I said, I wanted to show you how the effectiveness of pointers, correct? Why it is so powerful. Okay, so I'm going to show you something. It is can be a bit maybe eye-opening, okay, because you don't expect it. But let's see. Okay, so let's run this. Yeah, so can you all go to the poll and tell me what do you think will get printed out? Don't go and try to write the code all. Just tell me what you think will print out, and then we will go through. So just think about it, okay, and then just share what you think will get printed out if I run this code over here. Okay, so this again is not necessarily again part of your current coverage in a sense. Okay, but I don't think in the code, I mean the lecture slide so far, I don't think I saw casting of pointers. But again, like I said, this is one of the most powerful things of pointers that is very useful. Okay, so I think that's why everybody is giving the same answer 130. Okay, so let me let's run the code. Let's run the code. Let me see, where is it? Okay, so this is the code. Okay, same code. Okay, you're going to run it. Okay, so the answer is -126. Okay, so I think if I don't tell you why it's -126, you probably can't sleep for the next few nights. Okay, so I will tell you why it's negative 126. Okay, so again, this comes back to an underlying principle of how data is stored, okay, in the system and how we interpret data. Okay, so first let's look at this here. Okay, so let me try to explain. So integer, okay, like we know, is a 4 byte. Okay, the 4 byte variable. That means when I declare or I created this variable a, it is occupying 4 bytes. Okay, and I've set a value of 130. So of course 130 is a small value, smaller than 8 bits. So if I were to key in over here 130, I would get this value hex 82. Okay, equivalent to hex 82. Okay, so let's put that over here. So hex 82, if I were to look at it in binary, is 10000010. Okay, now what I've done here is I've created a pointer, character pointer, and I'm assigning the address of a, which is the integer, to pointer. So in order for me to do that, I need to cast. So that is where this casting comes in. So what I'm saying is I want to use a character pointer, but I want to point to an integer. So this is a very powerful thing. Why? Because regardless of how many bytes you have, you can use a character pointer to point to anywhere you like. Okay, so again, this is a very, very powerful thing. So this pointer that I've just created is now, okay, going to point to A. Okay, it's going to point to A. Now, when it points to A, okay, and I print out asterisk pointer, is going to extract out the character in this byte. Right, the character or the value in this byte. Okay, it's an 8-bit value. Okay, but what have we learned? We have learned that by default, character variable, okay, since this is a character pointer, a character variable by default is considered what? It's considered as a signed variable, which means that when I look at the most significant bit, is 1 is considered negative. That means I can't interpret it as 130. It's supposed to be the 2's complement of this. So 0, 1, 1, 1, 1, 1, 0, 1, and I add 1. So 0 carry 1. Let me see if it is correct. Did I read correctly? 126. So this is equivalent to 126. So this is equivalent to 126. And because of this, I need to put a negative sign. So this relates back to the representation of numbers, correct? So since a character by default is signed, when the most significant bit is 1, it automatically interprets it as a negative number. Okay, so if I wanted it to be sort of correct, that means the interpretation to be correct, then I should put it as an unsigned character. So if it's an unsigned character pointer, then it will print out as 130. Okay, well, because originally it was a signed character, okay, it is interpreting it as a negative number. Okay, so this again, I think what the key thing I want to show is how a character pointer can be used to point to anywhere you like. And using that, you can do a lot of things, correct? You can rearrange data, you can point to anywhere you like, you can extract information. Okay, so that's why again C is so powerful, because using a single pointer alone, as long as I know where to point to, I can take out anything I like. I can manipulate anything I like. All I need to know is the address or where you keep this information. Okay, and I can automatically point to the address and do whatever I like. Okay, so that is the powerful thing about C and pointers. Okay. Okay, so that is just additional thing. Again, I don't think I saw casting in your current set of slides, so you don't need to worry, but you probably see this more in 2106 and other modules. Okay, so there's one last exercise to do, which is this thing called a palindrome checker. Okay, so we will do this together. All right. This is again just to give you more hands-on, more practice. All right. So this idea of this palindrome checker is so a palindrome is basically any word or string where it is the same left to right and right to left. Okay, so you can start off with simple words like level, roto, kayak, or whatever, or again complete sentences also. Okay, so capitalization doesn't matter. Okay, you're supposed to do this: read in a string, and once you read in a string, then you just call a function to check whether it's a palindrome or not. Okay, so I'll give you a few minutes to start this first, and then I will sort of do this, okay, with you all just to go through the process. Okay, so I'll give you a few minutes to start first. Okay, so I will go through with you all, okay, step by step, and let's do this. So so you definitely need the hex include string. Okay, so since we are going to expect capturing of a complete string, that means even with spaces, okay, you want to have more space, okay, in terms of the array to capture the data, okay, and we can't use scanf because scanf will terminate with the space. All right, so we need to use other mechanism. Okay, so we can define buff length. Again, this is up to us. In this case, I'm just going to put it as 1024. That means that is the maximum number of characters we can take. Okay, so I'm going to say printf the string. Okay, so the alternative to scanf is fgetS. So it's a file get string. Okay, this allows us to capture everything, that means even the white spaces and so on. Okay, buff length and standard in. So this again is useful when you want to capture a whole string from the user. Okay, so let's do step by step. Okay, so I want to measure the string length after I capture the string. Okay, to explain the previous example. Okay, so let me go through this first. Okay, then I'll come back to that. Okay, so here we are calculating the string length. Okay, so let me just print this out here quickly. So okay, so let me just run this first to see. Okay, so key in Tom. Okay, so you can see that when I key in, let's say Tom, it gives me a string length of 4, whereas I only entered 3 characters. All right, so if I run it again, okay, Jane, it says 5, so it's always one more. Okay, and why is it one more? Okay, and the reason is because the f get s also captures your enter key. Okay, also captures your enter key. All right, so what we need to do is we need to make sure that this enter key is removed and replaced with a null character. Okay, so that you do not take that in when you are trying to do the palindrome. Okay, if all the palindromes would fail. Okay, so what we need to do is we need to remove that null, this new line, then /n. So what we can do is we can say that if buffer length -1 equals to the /n character, then I replace it with this, and then I reduce the length by 1. Okay, so again, why I'm doing this is because the capturing using fgetS captures the enter key, which is a /n. All right, so I want to remove that /n and replace it with a null character and reduce the length by 1. So that would make sure that I only capture the whole string without the enter key. Okay, so with this, now the length would be shorter by 1. Okay, so if I print this out one more time, okay. Okay, so you can see the original length was 5, then now it becomes 3. Okay, so now the next thing is I call the function to check palindrome. Correct. So let me create the function here. Okay, so I'm just going to give you some idea of how to do it. You can try it out again on your own later on. I think Colin will also upload the solutions to this. Okay, so you can also have a look. Okay, so I'm going to show you one possible solution. I think there's another possible solution which is using pointers. Okay. So this start 0 is for me to keep track of the start index. Okay, so what I'm going to do is basically I'm going to take any array. So if I take a string, okay, so if I say I key in the words roto, okay, so I will have a pointer to the start and the end. So this is the start and the end. Okay, then if they are the same, then I increment the start and I decrement the end. Then I check again. Same, then increment and decrement until I reach a point where they are both the same point or they are already crossover. Okay, so that is the technique, okay, or one of the ways of checking for palindrome. So the start is basically the starting point and the end is the ending point. Okay, the start of the string and end of the string. So you can create a loop, say when n is greater than equal to start. then okay, I want to compare if string start okay is not equal to string end, then return 0. That means it's not a palindrome. Correct. But if it is the same, that means I can proceed on to the next. Correct. That means I can say start plus plus and end minus minus. Okay. And if I can run through the whole loop, then I return 1. Okay, that means it is a palindrome. So here I just call the function if is palindrome buffer okay, length minus 1. Yes, that is it is a palindrome. Okay, so let's run this and see. Is that over this? Is that okay? So if I key in roto, it says yes. Okay, so let me remove this string length thing. Okay, but if I run it again one more time, but if I key in capital R in the beginning, then it says no. All right. So according to the specification, it's supposed to be independent of case. All right. So the easy way is I convert everything to uppercase or lowercase. Okay. So to do that, I need to include one more header file here. Include ctype.a. So this is for all the conversion between different types. Okay. So you can choose to either convert to all upper or all lower. So if I choose to convert to lower, I can do it this way. That means I take each character and convert it to the lowercase before I do the comparison. Okay, so now if I key in this way, it will say yes. Okay, so this is just again a simple code. I think Colin will also release the solutions. Okay, the other version to this is using pointers. All right, that means you declare both inputs here as pointer, one to point to the start of the array, the other to point to the end of the array, and then you just change the addresses. Okay, instead of using array indexing, use pointer notation. Okay, so I think that one I'll leave it to you to try and probably look at the solution. Okay, it's not much different from this, quite similar. Okay, so let me come back to the example here. So again, this casting is where you are using a character pointer in this case. So a character pointer points to a byte. So in this case, you're pointing to a single byte. Okay. So I mean, okay, another I would say another point is where do you point to, in a sense that how do you know that it's pointing here? Because the array is 4 bytes. Okay, it could point to the least significant byte, or it could also point to the most significant byte. Okay, so again, this comes down to another concept which you will be covering very soon, or maybe already in the slide, which is the format of multi-byte data. Okay, so it's either called Little Indian or Big Indian. Okay, LE or BE. So this concept of Little Indian or Big Indian is how data is organized. Intel processors generally use the Intel Little Indian system, which means that the lower byte is stored in the lower address. Okay, and a pointer will always point to the lowest address first. Okay, so in that sense, again, this works because when your pointer points, it points to the lowest address. Okay, but that part again, we will have a more detailed discussion when we look at it in MIPS. Okay, but for now, we know that the pointer points to the byte. So when I point and I extract out a character, okay, and I want to print it out. So when I print out, the pointer character here is pointing to this byte. And this byte, when it prints out, is interpreting it as a character variable. Okay, the character variable. Now, when I print it out as a character variable, I mean as a character type, that means this 8-bit data has the most significant bit as 1, which means that it is interpreted as a negative number. Okay, so from our number representation, we know that when I have 2's complement notation and the most significant bit is 1, it automatically means that it is a negative number, which means I can't just key this in a calculator and get the value. If the most significant bit is 0, then you can do that. If the most significant bit is 1, I can't do that. I need to first do the 2's complement. Okay, so when I do the 2's complement, I get the value which is 126. Then, since the most significant bit is 1, I need to put back a negative sign. So that is the final value based on interpreting this 8-bit data as a character. Okay, if you don't typecast, I believe you get a compile error. Okay, because it will not allow you to point to a different data type without casting. Let me just see. Okay, so it still sort of works, but in some cases the compiler might flag as error. Okay, so let me see now. Why string copy is used to access an element in a construct and not just. Okay, so when you create when you want to assign a string, okay, you can't just use the equal sign because the string name is in a sense a character array, which means it is a address of the starting of the array. Okay, which means that I can only assign it to an address. All right, the only time where you can do this assignment is during the declaration, where I also assign a value to it at the same time. Because once I get past that stage, then I need to look at it as a character array. That means you can't just assign a string to a based on the name of the array, because it needs to point to an address. Is there a function to check whether two strings are equal? Yeah, there are a lot of string functions. Okay, so I can't remember offhand. I think there's a is equal or something like that. Okay, so you can go and just go and search for string.h. Okay, for all the library functions. a pointer to an array. Yeah, so a pointer to an array you can use, yeah, either way. There's no difference. Okay, so basically this sort of wraps up the C and everything on that. Like I said, I know it's a huge overload, okay, for all of you, okay, so I can understand the stress and the frustration of having to cover so much of material, okay. But after that, we're going to go on to MIPS already, okay. Okay, so why we can't first store a copy of the string? I think yeah, should be fine. What you are saying should be fine. You can create a copy of the string, reverse it, and then string compare. It should work. Yeah. Okay, why you need to use string copy and not equal is because a character array, the name is the address of an array. That means you can't assign a value to it because it is treated like a pointer to an address element. Okay, only at the point where you create the variable, at that point you can assign. At that point you can assign a name. But once you are past that stage, you have to treat it like it is it's an array or a pointer to an address. So you need to use string copy where it will sort of do it the correct way. If you try to assign it, it is like trying to assign a value to a pointer, but a pointer is accepting it, is looking for an address. Yeah, A is equivalent to address of A or equivalent to address of A0. Yeah. So actually a lot of things I think you just try it out, you yourself can see. Like the if I come back to this example here, okay, so if I were to do this, okay, so if I take this and I copy one more time, and if I, instead of putting as address array 0, I just put it as this. It just the sorry, just the name. Okay, so I am back. Okay, so if you can see down here, okay, let me comment off this. Okay, so you can see over here, I use the address and the index element. Okay, here is ch array +1. Okay, so you can see here is the same. The values are the same. Whether I put the address and 0 or I just put the name, is still the same. Okay, so a lot of things that you have doubt about, you just go and try it. Go and try it, put in the code, and you should probably be able to figure it out. Okay, so I think that's all for today. So thanks for attending. I will release the recordings soon. Okay, and those who missed can probably watch it. If you want to watch it one more time, you can. Okay, so I'll see you all next week where we'll start on the MIPS. Okay. Yeah. So if any questions, you're free to WhatsApp me or email me or anything. Okay.